Based on research recently published by astronomers, they believe that Jupiter could make an ideal dark matter detector. It has been posited that if you would like to locate dark matter and you are unaware of where to look, a giant planet like Jupiter might be exactly the kind of particle detector that is required. Our solar system happens to have more than one gas giant. Of course, the largest and closest to Earth is Jupiter. Researchers recently released this information in a paper describing how the gas giant might hold the key to the discovery of the elusive dark matter. The nature of dark matter is one of the largest ongoing mysteries in physics currently. It interacts gravitationally. They can basically see it holding together galaxies that would have otherwise flown apart. But of course, it doesn't seem to interact with normal matter in other ways. The most popular of these theories posit that dark matter is some kind of particle that is either too small or too weakly interacting to be easily observed or detected. Particle accelerators and collider experiments have been set up to smash subatomic particles together. Researchers hope to see unexpected amounts of energy missing from the resulting collision, which would suggest some unknown particle, possibly that of dark matter, escaping the detector. But dark matter should be out and about in nature as well, and could be gravitationally captured by objects with large gravity wells, similar to that of our Earth, the Sun, and Jupiter. Over time, scientists expect that dark matter could build up inside a planet or a star until there is enough density that one dark matter particle might hit another, which would end up with both of these particles destroying each other. Even if one cannot see dark matter itself, they should be able to see the results of such a collision. It would produce high-energy radiation in the form of gamma rays. NASA's Fermi Gamma Ray Space Telescope, which was launched in 2008 on a Delta II rocket, has been used to examine the sky for sources of gamma rays for over 10 years. Researchers used the telescope to look at Jupiter and produced the first ever analysis of the giant planet's gamma ray activity. They hoped to see evidence of excess gamma rays created by dark matter annihilation inside Jupiter. As was explained, Jupiter's size and temperature makes it an ideal dark matter detector because Jupiter has a large surface area compared to other solar system planets. It can also capture more dark matter. You might then wonder why not just use the even larger and very close by Sun. Well, the second advantage is that because Jupiter has a cooler core than the Sun, it gives the dark matter particles less of a thermal kick. This in part can stop lighter dark matter from evaporating out of Jupiter, which would have evaporated out of the Sun. The research team's initial study of Jupiter has not found any dark matter. However, there was one tantalizing gamma ray excess at low energy levels, which is going to require further tools to properly investigate and study. They are really trying to stretch Fermi's limits to analyze such low energy gammas. Looking forward, however, they think that it will be extremely interesting to see if the upcoming MEV gamma ray telescopes such as Amigo and E-Astrogram find any Jovian gamma rays, especially at the lower end of our analysis, where Fermi's performance suffers. It is also possible that Jupiter still has some secrets to share. The Amigo and the E-Astrogram telescopes are still in the concept stage, but they may just be the tools required to find dark matter, and Jupiter might just be the target object in which to locate same. The research team believe that a similar technique could also be used to look for dark matter in Jupiter-like exoplanets, or cool brown dwarf stars, exoplanets and brown dwarfs closer to the center of the galaxy, where there are higher densities of dark matter, should appear hotter in infrared than planets and stars further away, due to more frequent dark matter annihilation in their cores. The James Webb Space Telescope might be able to provide an infrared survey of enough planets to corroborate this theory. Whether they find more evidence linking anything such as Jupiter to dark matter in any exoplanet or planet within our solar system, or whether they choose to find evidence of dark matter in our own gas giants close to Earth, such a discovery would mark a huge step forward in their model of the universe. There's no guarantee of either, but it's certainly worth a look, and the necessary work for this research is being laid at the moment. Like, comment, share, and subscribe. Let me know what you think about Jupiter being a major detector for dark matter. Thanks for watching, and goodbye.